So in this video, we're going to extend our conversation about the inclined plane and talk about another type of simple machine that's actually just a modified inclined plane. And that simple machine is the screw. So most of us know a screw as a type of fastener that's used to join two objects. But if we put our physics hat on, we can consider a screw a simple machine, as we've already mentioned, that works as a modified inclined plane. Now, this may not be self-evident, so let's take a look. So here we have a screw, and we can take a look at a particular region at a higher resolution so we can see and visualize the inclined plane. So if we look at the threading, which is the name for these individual curved surfaces that surround the screw, these are the threading. And if we take a look at that threading, we can see that this is actually just a curved inclined plane. It wraps around, sloped at some angle, all the way from top to bottom of the screw. So again, screws are essentially just modified inclined planes, and we can treat them as such. So the threads of the screw can be considered the inclined plane themselves, wrapped around the shaft, and they have many threads, which form a helical structure and convert rotational movement into linear movement. So the head of the screw will be rotated, and that rotation will see the screw translate typically downwards into the surface that they are being drilled into. Now the helix can be clockwise or counterclockwise, which corresponds to a right-hand and left-hand screw respectively. So if the helix is clockwise, then we call that a right-hand screw. And if it's counterclockwise, then we call that a left-hand screw. There are a few critical properties or factors that influence the nature and performance of a screw. And those include the pitch, threading, and turning directions. So the pitch we've already touched on without perhaps already knowing it, but the pitch is the distance between two consecutive threads. So again, if we take one of our illustrations and we mark a few of the threads, it's the distance between these that indicates or denotes the pitch. This is what the pitch is. So for a specific length of screw, the higher the number of threads, the smaller the pitch. So even though we could probably assume these two screws here on the left are the same length, let's focus in on one particular region of the same length. So if we take this specific length of screw, it is the one with the higher number of threads that has the smaller pitch. So that would qualify as this screw. This has more threads for the same length, and therefore the pitch is smaller. And we say smaller because the distance is smaller between them. If we look at the other screw, again, and we mark two adjacent threads, we can see this distance is larger than the distance between two adjacent threads in the other screw. So pitch is very important, and as we'll see in a moment, it also plays a role in the mechanical advantage. So therefore, the quality and efficacy and performance of a screw. Now, the other thing we need to talk about is the turning direction. We already mentioned that the helix of a screw can either be clockwise or counterclockwise. So let's take a look again with what we see here, and we notice, first of all, that the threading is in the same direction. It goes up from the left-hand side. So because of that, we can call this a counterclockwise screw. And again, these both have the same type of helix, so they're both counterclockwise, or in other words, left-handed screws. Now, the same is true for the one on the right. So if we wanted to determine which of these black arrows, the top one or the bottom one, reflects the direction the screw would need to be turned to be drilled in, which would it be? Well, if it's a left-hand screw, therefore the helix is counterclockwise, it needs to be rotated counterclockwise. So therefore, we would know that it's this arrow that indicates the correct direction of rotation. This is a counterclockwise direction. So like other types of simple machines, screws provide a mechanical advantage. And for screws, that mechanical advantage is equal to the circumference divided by the pitch. Now, we've already discussed the meaning of the pitch, but what about the circumference? Is it the circumference of the body of the screw, so this region of the screw, or is it the circumference of the head? Well, it is indeed the circumference of the head. This is very important. We want to make sure that we're referring to the correct regions of the screw when we're determining the mechanical advantage. And as a quick refresher, the circumference is simply equal to pi times the diameter. So the smaller the pitch, or the distance between threads, again, this is the meaning of pitch, the greater the mechanical advantage. This translates essentially to more rotations, but less force. So this is similar to the inclined plane. We're increasing the distance, and therefore we are reducing the force that's acting against the effort. So again, we can always refer to this formula for the mechanical advantage to remember this. And it's for this reason, it's because of the mechanical advantage that's afforded by screws that they're used so ubiquitously in many everyday tools. Because, yeah, we do have wood screws, which is probably the single most common and important example of a screw, but screws can take other forms, with two very common examples, including a C-clamp and a car jack. They may not be used as fasteners, but the simple machine of a screw is fundamental to their operation. So let's summarize the most important things we learned about screws. First of all, screws are a type of simple machine that works as a modification of an inclined plane. The threads of the screw can be considered as an inclined plane wrapped around the shaft. And a screw has many of these threads, which form a helical structure to convert rotational movement into linear movement. And the helix can be clockwise or counterclockwise, corresponding to a right-hand or left-hand screw, respectively. So again, clockwise corresponds to right hand, and counterclockwise corresponds to left hand. Then, of course, as a simple machine, screws provide mechanical advantage, which for screws is equal to the circumference, and remember, this is the circumference of the head of the screw, divided by the pitch, or the distance between threads. And again, the smaller the pitch, or the distance between the threads, the greater the mechanical advantage. This equates to more rotations, but less force.